just wanted to address one thing really quickly that I didn't do in the video, which is that we want to show this in real life with rulers where the car ends up in part B. So what we're basically saying is that we've got a ruler that goes from 0 to 200 centimeters, and the car starts at 20 centimeters, and then in 8 seconds it winds up here. All right, now in this next problem, let's go ahead and same idea. So after 5 seconds, we go from 200 to 120. So let's get our speed. So I go backwards 80 in 5 seconds, so I'm getting negative 16 centimeters per second. And I'm going to make a note here. You tell me why. Okay? And that word backwards is the key. So when we write down this equation of motion, it's going to be x is negative 16t plus 200, because that's where we start at. And we want to know where we'll be at 15 seconds, so x is negative 16 times 15 plus 200, which ends up being 160 plus 80, I'm just doing multiplication in my head, plus 200. I'm getting negative 40 centimeters. Let me just double check that. Yep, negative 40 centimeters. And so when we draw two rulers to show this in real life, what I'll show is the buggy starts here, goes backwards, and winds up somewhere back here at negative 40. All right, now to plot the position as a function of time, let's see. So I definitely want to make sure I'm labeling this right, so we'll say 40, 80, 120, 160, 200. That uses quite a bit of space here, so we'll say 200, 160, 120, 80, and 40. And this is going to be a little bit tricky because we're actually going down by increments of 16. I guess, you know what, maybe a better way to do it would be to go up by increments of 16. So we'll say 32, 64, 96, 128, 160, 192, and whatever that one works out to. So I'm really accurate here. So we'll say, so each of these are 16. So 32, 64, 96, 128, 160, 192. So 192 plus 32 is 224. Awesome. Yep. All right. So keeping this in mind, I would go about halfway up here to start, because each half tick would be 8. And I'm just going to go here 2, 4, 6, 8, 10, 12, 14. How did I know how to come up with those tick marks? I got to tell you, the real answer is experience. I don't have a good answer for you. I just lived the experience of doing these problems several times. So I know that here I'm going to go down 16 every, and that means that like a whole tick is 16 down here. Like each of these squares is 16. So I'll just kind of make sure I'm going down a whole square with each second that goes by. Yep, here we are, following the rule. And just kind of continuing here, let's draw this line. All right. Now here, the interesting part is to draw the velocity as a function of time. Yes, we need it negative. And again, this is position versus time. And just remember, this is position in centimeters, and this is time in seconds, we need to be careful. So this is velocity in centimeters per second for the second graph and time in seconds. And I'll just count off here. So we'll say 8. So we're going to count by 4s. 4, 8, 12, 16, 20, 24, 28. So we'll just say like 8, 16, 24. And these are negative signs. Notice you count down the way you learned in algebra. And so we get a graph that looks like, I'll just plot it here. Oops. 24, negative signs. And so I'll plot here a negative 16, going all the way across like that. And just labeling our axes, we can just make this 2 seconds, 4, 6, 8, 10, 12, etc. All right, so that is the, I don't know what page it is, 4th page.